Alright, so we're gonna solve minimum number of arrows to burst balloons, and this is a overlapping interval problem, and we just kind of have to think through it. So these are actually not points, we actually have to consider as segments. So for example, let's say we have two segments, okay? One segment starts here and another segment starts here. Okay, we have two segments here. Now, where do we want to place our arrow? If we place here, let's say like here, we want the minimum number of arrows, right? So if we pierce through here, actually this is not pierced, right? So that's very inefficient. Maybe if we want the maximum number of arrows, then yeah, that would be it. But actually we want the minimum number, so we can place it in the middle, maybe like here, and it will pierce these two segments. But what would be even better is to pierce at the end of our first segment, so that this gives the maximum space that we need. For example, let's say we have another segment that goes like like here. If we have placed in the middle, I mean at the starting index of our next segment, that's still won't pierce it. But if we place at the end of our first segment right here, it will pierce all three. So we have to sort our segments based on the end index. So end index, end index, end index, end index, end index, so that we can pierce as many segments as possible. And that's basically it. And if our arrow position is greater or equal to our starting index of the next interval, right here, our arrow position is greater, right, than the starting index. This starting index, let's say it has a value of 3, and this position is like 5. Okay, 5 is greater than 3, so that meets the condition. Now, what if its arrow position is right on the boundary, like maybe like, oh, we have it here, like here, right on the boundary. Actually here, 1, 2, 3, 4. Oh wait, no. Yeah, right here, along the boundary. Then actually we can pierce with one arrow right here, right? We can shoot an arrow at index 2 and it will burst this segment and this segment. So that's why it has to be greater or equal to. So let's do that. I hope the explanation was durable. And we're gonna do a lambda parameter of 2 lambda parameters, and we're just gonna do integer.compare the end index, so a1, not a0, minus b1. Well, you can do like the lambda way, like a1 minus b1, but I've done this and there's a edge case for like overflow. So by the way, lambdas don't solve the issue of overflow, so if that's the case, just use integer.compare. Okay, and let's say int count equals 1. Why is it 1? Because we initialize our first arrow position as the first point's last index. So point 1, this is point 0, this array, and we're gonna get the end index like this. So that's why count is initialized to 1. And we don't want to consider this, right? We want to start from I equals 1. So I equals 1, I less than points, the length, I plus plus, oh sorry. Okay, so if our arrow position is greater or equal to the next interval's starting position, then we don't do anything because this arrow will pierce through that segment. But if our next segment's starting index is greater than our arrow position, let's say this value has value 7 and this arrow position has 5, this arrow can't cover this starting position. So that's when we have to add another arrow so we update the arrow position to be at the at the end index of the next segment, like this. Okay, return count. Oh. Actually, wait, I don't. A1 minus B1. Okay. Ah, right. If you this is the lambda way, but if you want to use integer dot compare, as you saw the error, we need just one integer error, but this isn't the way. I mean, not one integer error. We need to pass two two parameters, a1 comma b1, like this. So submit. Oh, compare. Pair. Okay. And that's it. And I'll see you guys next time. Bye.